3-year-old was playing with my computer in the drawing program last night, and so I've had some, I don't know, I thought I would explore with some of the things that she changed. Anyway, that's why it looks so interesting. So we want to talk about identifying parallel and perpendicular lines and how to use those to solve problems and things. And this will just be the introduction, and then I'll try and do some examples. So find and identify parallel lines. So we'll start with parallel lines. Parallel lines. And the definition of parallel lines is two lines that go on forever, pretend that's straight, and they never cross. So if we go this way forever, it won't cross. If we go this way forever, it won't cross. And that's our parallel lines. The better way of saying this is our slope is the same. Okay, so our slope is going to be the same. If we ever have two lines with the same slope, it doesn't matter where we go, they're going to be the same distance apart. They're not going to ever cross. Okay, so slope is the same. And there's a sign somewhere in my classroom. Oh, it says parallel lines. They have so much in common. Too bad they'll never meet because they have the same slope. Okay, the only difference is they're going to have a different y-intercept. And remember, we call that B for this. So that's our parallel lines. And this is, again, just the introduction. And then our perpendicular lines cross at a 90-degree angle. Okay, and how do we know from an equation if they're perpendicular? Well, if we have y equals mx plus b, then our slope, it's going to be the opposite inverse. So let's just say that we had a slope of q. Q is our slope. So our equation would be y equals qx plus b. We'll do some numerical examples later, but just to start off with, I just wanted you to see that this is a general form. Then its perpendicular line would be y equals negative 1 over qx plus b. And we'll just do a couple of these really quick in Desmos, just so you can kind of see that this works, I guess. So we'll say y1 equals 2x plus 4, okay, and then we want a parallel line. So we're going to say y equals 2x again, and plus, I don't know, 2. And so these two lines are parallel. They'll never cross. They have the same slope, but different y-intercepts, and so they'll never cross. If I had put y equals 2x plus 4 again, I mean, they always cross, and that's because it's the same line. So that one doesn't count as a parallel line, and that's why they have to have a different y-intercept. Okay, so parallel lines, same slope, different y-intercept. Okay, and then we'll just say that red is our original line. For our perpendicular line, so our line that crosses at 90 degrees, it can have the same y-intercept, but it doesn't have to. So we're going to set that one to y equals the opposite and inverse. So the negative reciprocal of 2 would be negative 1 over 2 x. And you see that actually crosses because these are parallel lines. This is going to cross both of the lines at a 90-degree angle. We'll just say plus 3, that's in between the two. So then we have a perpendicular line, and that would be a 90-degree angle. Okay, hopefully that's just a quick intro to parallel and perpendicular lines. It should stop changing while I'm talking. Hopefully that helps give you an idea of what we're trying to go over.